Chapter number 3, Compound Interest using formula. First we'll understand what is the meaning of when interest is compounded yearly. Interest is calculated and added to the principal once every year, that you know. So each year you are earning interest on the original amount plus any interest that has already been added. Now let us see what formulas are used in this chapter. There are three types of sums as mentioned below. Whenever you have to find out the amount, you have to use this formula, P into 1 plus R upon 100 whole raised to N, where A is equal to amount, P is equal to principal, R is equal to rate of interest compounded yearly, N is equal to number of years. So some numbers to be solved with above formula from 3A are as follows. Here it is mentioned, we are going to see that also how it is going to be solved. When the rates for successive years, now another formula, when the rates for successive years are different, that time what formula should be used? This only, but only rate is different, that's why this way we have to write. A is equal to P into 1 plus R1 upon 100, 1 plus R2 upon 100, 1 plus R3 upon 100 dot 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 and so on. Means as many different rate of interest are given, that way it will increase. To find the principal, A is equal to P 1 plus R upon 100 whole raised to N. This is the formula. Whenever the CI is given, compound interest is given, that time you have to use this formula. That is CI is equal to P 1 plus R upon 100 whole raised to N minus 1. Now here why 1 is here? Because in the formula actually here it is P is there. So when this P and this P we take out as a common, then here P will come and here 1 will come. So this way we will use this formula. Whenever you have to find the rate percent, amount formula you use. A is equal to P 1 plus R upon 100 raised to N. It depends on the situation. If the CI is also given, if this way it is given, here also you can find out the rate of interest. To find the number of years, so here A is equal to P 1 plus R upon 100 whole raised to N. So this formula also you can use whenever you have to find out N. N means number of years. Chapter number 3, Compound Interest, 3B. Ninth sum, let's solve. Simple interest on a certain sum of money for 4 years at 4% per annum exceeds the compound interest on the same sum for 3 years at 5% per annum by rupees 228. Find the sum. Here you have to find the sum means the principal, and here this is the main condition which is given, which tells you the exceeds means difference between simple interest and compound interest. So here sum is not given, but the simple interest and compound interest, their conditions are given and the difference between them is given, that is 228 for simple interest. What is the time and rate of interest that is given, and for the compound interest also what is the time and the rate of interest is given. With the help of this, by assuming principal X, we can solve it. Let's start. P is equal to X. This is in the case of SI. P is equal to X. R is equal to 4% and time is equal to 4 years. So now SI formula you know. SI is equal to P into R into T upon 100. Put the values. P is X, R is equal to 4, time is also 4 upon 100. So when you will calculate it, 4 4s are 16 X upon 100. This is your SI. And here you just write down about the CI. Here also P is equal to X, R is equal to 5%, time is equal to 3 years. So now CI is equal to, as we know the formula of CI, A minus P is equal to, as I told you before, 1 plus R upon 100 raised to N minus 1. So let's write here P is equal to X only. Put the values. R is equal to 5, 100 whole raised to N is 3 minus 1. Let's solve. X will as it is. Now here this will become 100 into 100 plus 5, 105 upon 100 whole raised to 3 minus 1. So is equal to X here. Now this when you will reduce by 5, you will get 21 upon 20. By 5 you have to reduce it, raised to 3 minus 1. So X 21's cube is 9261, and 20's cube is 8000 minus 1 is equal to x. Here 9261 minus 8000 into 1, 8000 upon 8000. So here x, 9261 minus 8000 is equal to 1261 upon 8000. This is your CI. Now the difference between them is given, that is SI minus CI. Listen carefully, the difference between SI and CI, not the difference between CI and SI. So SI minus CI is equal to, that is given 228. Now put the values which we got. 16 upon 100x minus, as I showed you, 16x upon 100 minus CI is equal to x, 1261 upon 8000. So right here 1261 upon 8000, x is equal to 228. Now you have to find out the LCM of 100 and 8000, that is 8000 only. So what is the LCM here? 8000. You should be very quick to find out this, and you must know this rough work you must do. So after that, I want to convert this 100 into 8000, so it should be multiplied with 80, and as you know this is multiplied with 80, so this also should be multiplied with 80. Then minus 1261 upon 8000, x is equal to 228. Now 16 into 80 is equal to 1280 upon 8000, my x minus 1261 upon 8000, x is equal to 228. So the difference is coming when 1280 is subtracted from when 1261 is subtracted from 1280, we get 19. We get 19 upon 8000, x is equal to 228. So x is equal to 228. Now this will go to right hand side, so we will take the reciprocal. So 8000 upon 19. So x is equal to, in such situation, children, always you have to find out that whether this number is divisible with this or not, that you must check. And if I'll find, so I will come 19 ones are 19 and 19 12s are 228. So now 12 into 8000 you have to do. So you will get 96,000, as x means the principal is equal to 96,000. Thank you.